everybody, welcome to 3.8 Linear Quadratic Systems. Today we are going to see what happens when a linear relation is graphed at the same time as a quadratic relation and what types and how they can intersect each other. So we're going to use a little bit of knowledge from previous courses in grade 9 and in grade 10 to figure out the solutions to our system. So in grade 9 we looked at solving linear systems where two straight lines intersect each other. We did that graphically, and when those two lines intersect each other, that was the solution, was the point that they crossed. In grade 10, you used all of your methods to do that algebraically. You looked at substitution and elimination. And in grade 11, we look at what would happen if a parabola crossed a straight line. There's a couple types of results that we can get. We can have kind of the one that you would probably think of is this middle one. You have a parabola and a straight line crosses it. Somehow it should cross in two places. That would give you two real solutions. The other way is that if you slide that line down, it might cross it only at one point. It's just going to touch the parabola, but not actually cross it in two places. So you could have one solution or one real solution. And yep, it's possible that our parabola opens one way and the line of it, the line that we have, never intersects it at all. So it is possible to have no real solutions. Okay, so your parabola can cross, your line and your parabola can cross once, twice, or not at all. All right, we're really just going to look at two ways to do this. We're going to look at it algebraically. We're going to look at it graphically. The word problems, guys, go to your textbook, okay? So solving algebraically, if it's set up nicely for you, here we go. We have got a straight line and a quadratic. And I'm going to use my method of substitution. I'm going to take this one right here, and I'm going to substitute the other one into it. So watch what happens. Instead of y equals this, since I know y equals 2x plus 6, I'm just going to put 2x plus 6 and replace my original y value. Okay. Now I need to bring all the values onto the other side of the equal sign. When I bring the 2x over, it's going to be a negative 2x. Oops. So there is my x squared. When this 2x comes over, it's going to be 4x minus 2x. And when this positive 6 comes over, it will be a negative 6. Reduce, and you should get a new quadratic. So 0 equals x squared. Now 4x minus 2x is 2x, and plus 3 minus 6 is minus 3. We have ourselves a new quadratic. So if I want to know the roots or the solutions, really what I'm doing is I'm looking for the roots of this new quadratic or this new equation. And this will tell me the solutions or the points of intersection of my straight line and my parabola. Okay, so here's my new equation. We have to figure out what x is. You can do it a couple ways. You can use your quadratic formula, or you can use factoring, or whatever method comes to play. I do want to use the quadratic formula because I want to show you something. And I'm going to use the pen tool just so I can explain a little bit better. Again, I'm sorry for the messiness when I use the pen tool. All right, I'm going to start up here. So, oops, pen tool. Where did you go, pen tool? Pen tool. There we go. All right, so x equals negative b. This is my b value. Okay, so negative 2 plus or minus b squared, okay, 2 squared is 4, minus 4a is 1, and c is negative 3. So 1 and negative 3. Okay, oh, all over 2a, and our a value is 1. Okay, so negative 2 plus or minus 4 minus 4 times 1 times negative 3. This becomes negative 12. 4 minus negative 12, that's the same as adding 12. This should give us 4 plus 12, which is 16. Okay, all over 2. Now, if you remember from a couple sections ago, this part here under the root sign, this is called your discriminant. Because there is a real value under here, we would end up with 2 possible roots. Okay, so you can use that idea of your discriminant to figure out how many times your line would intersect your parabola. Okay, so we know that the square root of 16 is 4. So 2 plus or minus 4 over 2. So my possible solutions are, well, negative 2 plus 4 is 2. 2 divided by 2 is 1. The other possible solution is negative 2 minus 4, which is negative 6. Negative 6 divided by 2 is negative 3. So these are your two possible x values. Okay, so we found your roots or your solutions to the system. Okay, sorry, these are the x values to your system. If you want the solutions, you do still have to find out the y value. You can take these, you can substitute them into either one of your original equations. I'm going to use the linear one because it's an easier equation. So if I wanted the actual coordinates, take 1 and substitute it in here. 2 times 1 is 2. 2 plus 6 is 8. So this particular point of intersection would be 1, 8. And the other one, negative 3, if I take negative 3 in here, 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. So my other point of intersection would be negative 3 and 0. Okay? Now, in order to solve this graphically, what you can do is take these and graph them. Y-intercept is 6. Slope of 2, I'm going to go up 2 and over 1. You could draw your best straight line, and then you've got this quadratic. You may have to do a table of values unless you're more comfortable with graphing a standard form. At this point, I'm going to tell you to, I mean, if you're great with by hand, wonderful, but come on guys, we've got technology in front of us. Let's use it. So x squared plus 4x plus 3. So y equals x squared plus 4x plus 3. Did that come out? There it is. Beautiful quadratic. And we're going to graph our straight line. Y equals, oh, old age. What was our equation? 2x plus 6. Y equals 2x plus 6. There it is. And let's just back up here so we can see if we did actually get the correct roots. I've got one at negative 3, 0. And positive 2, positive 1, positive 8. So we've got 1, 8, negative 3, 0, and that's what we ended up finding. Okay, so substitute just like you did in grade 10, find 2 points or 1 point or no points. You can use technology if you want to graph it, unless you really love graphing by hand. And we can use our discriminant. We can use our discriminant to figure out if there's going to be 1 point of intersection, 2 points, or no points. Okay. This next example, it was basically the same idea, was using the discriminant to find out. We'll just do the algebraic part and then you can use Desmos. So in something like this is pretty similar to the other one we had. It doesn't matter which equation you substitute into the other equation. When I look at this, I notice that I could take x squared minus 6x plus 8, and I can substitute it in for the y value here. Otherwise, you can just rearrange and substitute it in. So let's take a look. So instead of having 2 times y, I'm going to have 2 times whatever that is, and then plus x equals 4. You didn't have to solve it this way. You could have isolated for y and plugged it in. Okay, now I'm going to take the 2 and distribute the 2 into the brackets. So this is going to be 2x squared minus 12x plus 16 plus x equals 4. Bring the 4 onto the other side and collect my x's. So when I collect my x's, this should give me minus 11. And when I bring the 4 over, it should be positive 12. Remember, okay, now I'm going to pop over to my pen tool. Okay, remember this is our A value. Okay, A is 2. B is negative 11. And C is 12. 12. So I've got my A, B, and my C value. I'm going to use my discriminant of the quadratic formula. Remember that was B squared minus 4AC just to see how many roots there are, because the question asked us how many points there were to satisfy the system. In other words, how many solutions or roots are there. So I'm going to take 11 squared minus 4 times 2 times 12. 11 squared is 121. And 4 times 2 times 12 is 96. There we go. Sorry, negative 11 squared. Remember, your negative 11 should be in brackets, but you would still get a positive 121. 121 minus 96, you should get a positive 25. Because this is a positive number, you would get 2 roots, okay? So that's all this one was asking. The word problems, guys, look in your textbook. Good luck with your work. And you finished chapter 3. Give yourself a pat on the back. You guys did a great job. Good luck with your task. It's not meant to kill you. Have some fun with it and hand it in when you're ready, okay? It is due, I believe, next Friday. Good luck, guys.